Hi, this video is going to be the first part of 2 or 3 videos, I think it's 2, on solving multi-step equations. We've learned some really great methods. Combining like terms, the 3 videos on that is coming together for this. This is bringing all of that together. And also the properties that we used, we're going to be using that just like we were in the other problems. So, the first thing I would want to point out is, in the tool bag, I have the same 4 steps that we were doing with combining like terms, but also I've actually added an extra step, which is solve. After we've combined like terms and made it look all pretty, which is what we've normally been doing, so that's the combining like terms part, we're actually going to solve the equation once we've made it a lot easier to work with. So, here we go. Example number 1. There's 3 examples, and this is the first one. Obviously, because it's example number 1. So if we've got this, the first thing I'm going to say is, well, look, we're going to look on each side. 25. 25 is by itself, so we're not going to mess with it. It's completely on its own, and we don't need to combine anything to make it look better. It looks pretty good. Over here, we have 3x plus 5 plus 6x minus 7. And well, yeah, that is kind of a mess. If you look at it, we have 2 different x's and we have 2 constants. So we're going to narrow it down and combine like terms and make it look better, make it look nice. So here we go. My first step is I rewrite. (3x plus 5 plus 6x). I'm going to add the opposite, turn that into plus negative 7. And that's going to be over there. So that's my first step, rewrite. Second step, distribute. There's no parentheses. There's no reason to distribute. That's another thing we're going to be doing on example number 3. If I have a reason to distribute, I would do it there. But I have no reason to distribute. Rearrange, absolutely. Variables in the front, constants in the back. There's only one type of variable because that's what we're solving. We're solving for x. So I'm going to just get out my colored pencils so we can get a nice little picture going. So we've got 3x. Then we have, let's see what we got. Let's go with the brown. All right. And then we have constants, right? Okay. So I'm going to put the greens in the front, browns in the back. Equals 25. All right, here we go. We're going to combine like terms. I'm not going to start factoring anymore. We should know 3x plus 6x is 9x. We should be at that point now where that's making 9x. 5 plus negative 7 is negative 2. More negatives. Negatives have more voting power. Equals 25. And now I'm going to start rewriting. Before I rewrite, now I'm going to start solving. Before I solve, I'm going to rewrite first because I need to know I got here. I got to 9x plus negative 2 equals 25. This question, I'm going to give you something like this on our standards test, and this is it. I'm just going to tell you, turn it into a 2-step equation and stop. And that's this right here. I'm going to rewrite exactly like this so I don't change it, so I know where I was at. Now I'm going to change this one. So now we're solving this equation. And I'm solving it, well, let's take a moment and think back in time. This is all back from the first unit. This is from the first unit. Solve it just like that. I have 9x plus negative 2 equals 25. I'm going to add the opposite. The opposite of negative 2 is positive 2. Right? Well, here's a 0 pair. 9x equals, oh, better bring my bounce line down a little further. 25 plus 2, 2 plus 5 is 7, so we have 27. Okay? I'm going to rewrite. Remember, this is all from 2-step equations. We rewrite. Because I'm not changing this one, I'm changing this one. 9 times x equals 27. The inverse operation of multiplying is The inverse of multiplying is dividing. Divide both sides by 9. 9 divided by 9, that's the identity of multiplication. See, we're going to start using those words. This is the additive identity. This is the multiplicative identity. This equals 1. 1 times x is x. And 27 divided by 9 is 3. So I'm claiming, after all this great math work, the answer is x equals 3. Now we got to do our check. 3 times sum x plus 5 plus 6 times sum x minus 7 supposedly equals 25. Well, we think the answer is 3, so let's plug it in. There's 3, and there's 3. Order of operations, I'm going to keep my equal sign nice and leveled. 3 times 3 is 9, plus 5. 6 times 3 is 18, minus 7. Okay. 9 plus 5 is 14, plus 18, minus 7. Okay. 4 plus 8 is 2. Carry to 1. You got 32 minus 7. Does that equal 25? Absolutely. 25 is equal to 25, and check. We're good. So, the check is going to be a little more crazy. That is. But look over here. All we did was combine like terms to make it look like this, and then we solved a two-step equation. That's all there is to this section. So, here we go. Example number 2. Example number 2. 4c minus 5 is equal to, I apologize, my cell phone turned off. Now, 4c minus 5 plus 14c is equal to 67. Let's do it. 4c, not 5c. Apologize. Equals 67, okay? Let's go for it. I'm going to rewrite. First step, I'm going to add the opposite with negative 5 right here. Okay, do I have to distribute? Nope. Do I need to rearrange? Yeah, you got a constant in the middle, variables in the front. Those are my greens. Only constant I have is negative 5, so he's hanging out by himself. Got to keep the negative. If you lose that negative, you will get the wrong answer. You have to watch those negatives. 4 plus 14, that's 18c, plus negative 5, this is 67. Now I'm at my solve this two-step equation. I'm going to rewrite. See, opposite of negative 5 is positive 5. I have a 0 pair, that's my additive identity. Right? That's my additive identity, so now I have 18c. See, 5 plus 7 is 2. Carry to 1, 72. I'm going to rewrite so I know where I was at. I know lots of rewriting. See, inverse of multiplying is still dividing. 18. I don't have my times tables memorized for 18 and going up. Oh, forgot my... No, we're good. Sorry, I forgot something. So, but I don't know that. But I know how to simplify. And I know 72 and 18 can both be divided by 9. Right? Okay, so 72 divided by 9. 8 times 9 is 72, so that's got to be 8. And 18 divided by 9 is 2. Oh, I totally know what that is. 8 divided by 2 is 4. So I think C equals 4. If you think it, show me you believe it. So we're going to check our answer. 4 times some number, don't know what it is yet, minus 5 plus 14 times some number is equal to 67. Well, I think the answer is 4. So I'm going to prove it. 4 times 4 is 16 minus 5 plus, I'm going to do a little math up here. See, 14 times 4. 4 times 4 is 16. 4 times 10 is 40. 6, 5, 56, right? Okay, I'm going to add and subtract left to right. 16 minus 5 is 11 plus 56. Well, 1 plus 1 is 7, and 1 plus 5 is 6. Sure enough, hey, check it out. The answer is 67 equals 67. Is my check all right? Yep. So my answer is definitely C equals 4. So, zoom out a little bit so you can get a good picture of it. So there is my equation. We're good to go. That's number 2. Here we go. Our last and final example. Now comes a good one. Example number 3. I'm going to zoom in on this so we can focus on this. Yep, we got fractions. Yep, it's good times, ain't it? There's a few ways we could do this one. I want to use a property to do this. I'm looking at all of these, and I know, well, I know 6 times 2 is equal to 12. Right? And I know 3 times 4 is equal to 12. And I know 4 times 3 is equal to 12. Mr. V, what does it all have to do? Well, think about it. We have to have a common denominator eventually. So I know the least common denominator is 12 because all of these, 12 is 12 already. 6 times 2 is 12. 3 times 4 is 12. 4 times 3 is 12. I found a common denominator for all of them. So you might be thinking, well, now we're going to convert to common denominators. I don't want to. I think there's actually a different way of doing this, and we're going to use that starting today. Clearing the denominator is a great method. There's a reason why it's such a great method. Normally, I would think about if I had some number. If I had m divided by 12 is equal to 2, what would you do to both sides? Well, the opposite of dividing is multiplying, so I would multiply both sides by 12 and solve for m, wouldn't I? This equals 1. Well, it's the same idea. I'm going to multiply both sides of the equation by 12. So, here we go. Start by writing the equation. Alright, here we go. Times everything by 12. Both sides get multiplied by 12. And you might be thinking, great, now this is going to be turned into a headache. Hold on, just give me a minute. I've always told you that with order of operations, if you remember, I always write it like this. If all you're doing is multiplying and dividing, you can do it out of order. Check this out. I'm going to take the 12s right here. Well, I'm going to hold off on that just for a second. This is 7 over 12. First off, yeah, I'm going to take distributive property. This is distributive property. Now I have to distribute. 12 times 3m over 6 minus 12 times m over 3 plus 12 times 1 over 4. Okay? Here we go. Now comes the fun part. 12 divided by 12 is 1. So I'm just going to put a 1 times 7 real quick. Okay? 12 divided by 6, that's 2. So this is 2 times 3m. Because that's what's on top. Minus, well, 12 divided by 3 is 4. So we're going to have 4 times m. Plus, 12 divided by 4 is 3. 3 times 1. No more fractions. That's the whole point. Distributive property got rid of all the fractions. Here we go. 1 times 7 is 7. 2 times 3 is 6m. Negative 4, this is just going to stay minus 4m. Plus 3. Done. No more fractions, and now look how easy this is to do. 6 minus 4, 2m, plus 3. That's all we have to solve now. There's no fractions, there's no denominators, and now it has become such an easy problem to deal with. Because we took a moment and did a really hard idea, now it's really easy. And that's the whole idea of this. These properties save so much time. We don't have to find common denominators. We don't have to add. We don't need to multiply by a reciprocal. This is it. I'm going to rewrite. Opposite of positive 3 is negative 3. This is a 0 pair. 7 plus negative 3 is 4. I'm going to rewrite. Oh, I automatically jumped it. Did you see what I did? I always do that. For me, that's what I would do, but for you guys, we'll do it. We'll wait. The opposite of dividing, or sorry, the inverse of multiplying is dividing by 2. So m equals 2. I think that's the answer. If you think it, prove it. A lot of work, isn't it? No matter what you do, you're going to do a lot of work. No matter what you do, there will be a lot of work. So it's just a matter of how you decide to do it. Three times some number divided by 6 minus some number divided by 3 plus 1 over 4. Well, I think that number's 2, right? So I'm going to prove it. 7 over 12 is equal to 3 times 2 is 6 over 6 minus 2 over 3 plus 1 over 4. We know what 6 over 6 is, don't we? That's just 1. I have a whole pizza. I take 2/3 away. So I'm going to common denominator. If I take 2/3 away from a whole, that equals 1/3 plus 1/4. Common denominator between 3 and 4, definitely 12. Right? Well, I gotta times this one by 4. Gotta do that up here. I times this one by 3. Gotta do it up there. So we got 4 12ths plus 3 12ths. 4 plus 3 is 7 over 12. 7 over 12. A lot of work. But we're definitely right. The answer is m equals 2. A lot of work for one problem. But it just takes time going through it It'll be all right. So, see you next time for part 2. Have a great day.